All right, let's look at the practice exam 3, problem number 3. All right, so we want to find an equation of the tangent line to this given function at the point 0, 1. All right, so since 0, 1 is given, this is going to give us the y-intercept. So I'm going to use the slope-intercept form. So we have, first, we're going to try to find the intercept, the b, which is going to be equal to 1, right? Because when x equals 0, y equals 1. So that is the y-intercept, right? Then we want to find the slope m, right? M can be found by simply find the derivative of the function and plug in the x value of the x coordinate of the point of tangency. So in this case, x is 0, right? So in order to find that, we need to find the derivative first. Let's take the derivative. So y prime is equal to, all right, so you have a power rule here, so put 2 in front. All right, keep the inside function as it is, so you have e to the 4x minus 2. Then we subtract 1 from the power, so you get 1. So I'm not going to write that because it's confusing. All right, then you have to do a chain rule, multiply by derivative of the inside function. Right? Derivative of e to the 4x is e to the 4x. Then multiply by derivative of the power, which is going to be 4. Right? And the derivative of negative 2 is 0. So this is it. Right? We can simplify this by simply combining 2 and 4 together. That's going to give us 8. And we can put e to the 4x. So next here. And the last one, so you have a quantity e to the 4x minus 2. Right, so quantity e to the 4x minus 2. Right? So this is the derivative. So in order to find the slope at x equals 0, we just have to plug in x equals 0. Right? So we have 8 here, so I'm going to write down 8. Right? If you plug in x equals 0, you get e to the 0, which is going to be 1. Right? And again, e to the 0 is 1, minus 2 is negative 1, so it's going to be negative 1. Right, 8 times 1 times negative 1 is obviously negative 8. All right, so therefore, using a slope-intercept form, slope is negative 8, x plus b, which is 1. All right, so this is an equation of the tangent line we're looking for. All right, that's it. I hope that this was clear.